Hi, my name is Graham Harding. I am the digital lead for cost management, or PCC, project cost consultancy at AirCom for our Middle East and Africa region. My presentation today is on 5D, or rather question as to what is 5D? Is there in fact a fifth dimension? And if there is, does it have a place in BIM? What triggered the question is that I recently had a conversation with a colleague who stated that 5D BIM doesn't exist. And I've too found the term to be a bit of a misnomer, in that the name potentially is incorrectly applied. Misnomers often arise when something is named well before its true nature is understood or known. So let's have a look. Let's see if that's the case. To start, we've got to understand where it comes from. So 3D and 4D, we know the first three dimensions being height, width, depth, are physical measurable dimensions representing objects, and multiple objects in a construction model or in a building represent what we intend to build. When we then look at the fourth dimension, which was known to be time, and we apply time to each of those objects, we can get the construction schedule or construction program, which represents the sequence and the order in which we intend to build that structure. But when we look for suggestions as to what a fifth dimension could be, you'll find that there isn't a lot. As mentioned, my colleague stated he doesn't believe that 5D BIM actually exists, and this could be true purely as a comment in terms of uptake. And myself, despite being a quantity surveyor and really needing there to be 5D BIM in order to have something to reference what we're doing and to bring our industry into BIM, was wondering if that statement that he made actually made sense. And, you know, considering it to be a misnomer, I've obviously had that feeling for a while. And in preparing for this presentation, I was looking for something to confirm that there wasn't, in fact, a fifth dimension physically. And what I found was an article that spoke to the mathematics and the mathematical stance behind the fifth dimension. And what it explained was that the fifth dimension came around because physicists were trying to connect all the parts of the universe, or the known parts of the universe, in a way that made sense. They wanted to connect the fundamental forces that they knew of in a way that made sense. And it didn't necessarily represent itself in a dimension, but that connection and that comment about connection and sense speaks to the interpretation of 5D within a BIM environment, in that the fifth 5D therefore is the connection between 3D and 4D data in a way that makes sense. And in this case, that is by applying value to both the 3D objects and the 4D time of a construction project to arrive at a cost. So unpack that 5D further, and what we've got is we effectively break it down into three sections, or three components to arrive at a 5D simulation. First of all, we have to determine the quantity of all objects in a model, and group those like objects together. And once we've determined the quantity of all objects in a model, we then have to determine and calculate a cost for each type of object, and apply that cost to each object or each instance of an object in a model or building. And once that's done, we then have to represent those costs along a timeline by making reference to the construction schedule or program and each object start and end time. So that sounds simple enough. We know what we've got to do. We know that there's 3 steps. We've got a roadmap. So why is this not common practice? Why don't we see this happening on every project? And the reason potentially behind that is that within 5D, there are a lot of misconceptions about it and what its intention is. Misconceptions like all quantities can be obtained from a model, and similarly, all materials can be ordered directly from the model. And if that's the case, we're saying that bills of quantities and estimates can be produced with the click of a button, which they can't. And But if they could, then BIM would reduce the amount of time required by a quantity surveyor and possibly negate the need for a quantity surveyor altogether. And as such, BIM is about design, it's not about costs. So where does cost in 5D actually fit into BIM? And while these items are misconceptions and they don't accurately reflect the current capabilities or intent of 5D BIM, they do provide some direction and consideration in what we could achieve if modeling geometry and parameter property data mapping could be made more consistent and had more attention paid to it in terms of 5D requirements. We can then look at a few more challenges, and I think what we'll do is we'll go through a number of quantity takeoff challenges, start with some high-level ones and then a number of sort of detailed ones, particularly for our model author colleagues who are listening and watching, to be aware on the next model that you produce. But at high level, it's important to note not all quantities needed during takeoff can be extracted from a 3D model. Examples such as finishes to surfaces or formwork to concrete or other items that are associated with the finished product or informing the finished product, because not all of these items are modeled. And if they're not modeled, there is no quantity associated with it. Similarly, not all items that would typically be considered measurable are modeled. This is as objects in the model are that they're just placeholders. They're graphical representations of the finished object, and they do not necessarily include quantifiable details of all of the measurable parts that are required in order to cost the final object. They may be a graphical image that does not give the actual dimensions of a component. So we need to ensure that if that's the case, and those items are used in the model, we need to ensure that those placeholders contain data that informs the cost model as to the final product, so that a provision can be made for it. And another issue is that the reason is that traditional cost estimating and scheduling is an information take process, and that quantity surveyors take information from the design and that they don't necessarily contribute directly to it. But the truth of the matter is that there is no 5D without 3D or 4D, and at the same time, 5D is entirely dependent on the quality of the data that it receives from the 3D and 4D model. Now, some of the detail that we look at is, well, all of the detail that we look at is Revit based. The model authoring tool of choice for many of the consultancies that we work with and within our own company is Revit. So all of our exposure has typically been on Revit models. And it actually, some of the issues and challenges we face start with the fundamentals of Revit. In Revit, the way it's structured is that object in a Revit model belongs to a family or a category. And Autodesk state that a family is a group of elements with a common set of properties, which they call parameters, and have a related graphical representation. They've tried to create a family structure to align with how objects would be assembled on a construction project. So to this end, there are three different types of families, namely system families, and loadable families, and in place. System families basically create the elements that you would assemble on a construction site, such as your walls and roofs and floors and ducts. These system families are predefined in Revit. Loadable families are families that you would create to create building components that would usually be purchased and delivered to the site and then installed into the building. So things such as doors and windows and joinery components and other fixtures and furniture, HVAC and electrical components, etc. But then your last category is your in-place elements, and they're typically unique elements that are created to represent a unique component for a specific project. But unfortunately, the family structure, which forms the basis of Revit models, doesn't align with the required estimating procedural guidelines that's implemented in many of the geographies. And we've tried to get around this by using the application of a 5D classification parameter but we're still finding that there are issues on the basis of how the models are put together, and that these families and categories, while efficient for modeling, don't necessarily talk to construction sequence. If we get into a few more of the detailed issues regarding Revit specifically, as a starting point, we can ask the question of, how are we receiving the model? Are we receiving it as a federated model? And federated models are our preferred option. A federated model is one in which the individual design disciplines link to a central model rather than merging all of the models into one integrated model. And this, using a federated model, allows the quantity surveyor to turn the respective models on and off in the view settings, depending on the information that we intend to see. But it's important to note that if you're using a federated model, that the quantity surveyor will need to receive all of the models, because from a quantity surveyor's perspective, a linked model appears as a single object within the other models that it's linked to. It is therefore not suitable for quantity takeoff or for cost modeling. And this means that, for example, an architectural model should be separate from the structural engineering model and the MEP models, and that they should be distributed as separate files for quantification purposes. It's also important that we manage the coordination of elemental ownership between the different design disciplines, and we'll need to address that in a BIM execution plan in order to prevent elements being duplicated or missed. Obviously, if a model object isn't modeled, it can't be quantified, and likewise, a duplication on either discipline drawing will result in an overcalculation. At this stage, it's, we could talk to design options, but I think options is something that we can accommodate in Revit, but one option needs to be costed at a time and costed holistically, and then we can compare design options. It's very difficult to isolate quantities for options. And in that regard, when you issue a model, the model should represent the net finished structure for the selected option as it is intended to be built. And that if in the event that design options are to be investigated, as I said, each option should be investigated as a separate model for costing purposes. Project units, if not standardized, can be a nightmare for a cost manager and a quantity surveyor to try and handle. Particularly for our calculations down the line, those calculations are dependent on consistency of units of measure. So in Revit, we know that we have common units of measure, we have structural units of measure, and then our services units of measure. And what we found is that it's typically your lengths, your areas, and your volumes that are most important to quantity surveyors. And what we try and do is we standardize those across the typical dimensions. So within each of those project unit groups, we try and always make sure that linear dimensions are represented by meters with 3 decimal places, allowing us to go down into fine units and effectively extract millimeters from that if necessary. But then to keep it consistent, all area measures are by square meters and all cubic measures are measured by cubic meters. Again, all rounded down to 3 decimals so that we can represent a millimeter measurement if necessary. In terms of object visibility and graphics, one of my colleagues who was introducing me to Revit, and this is where it stuck out, said that I need to be aware that one of the most powerful features of the software is its ability to hide information. So from a design and a model author's perspective, when issuing a model to a cost manager or a quantity surveyor for the purpose of estimating, make sure that you have all of your information being shown. That cost managers and quantity surveyors aren't familiar with your software and do not have the wherewithal and the ability to go in and turn on your visibility graphics that may have been turned off. So make sure that you are showing them all visible information that the cost manager would require in order to complete an estimate. If it's not shown, it won't be quantified and therefore may result in a shortfall in the estimate. But that said, the main role of a cost manager is to try and identify the missing spaces and fill in those gaps. At the end of the day, there is no LOD for a cost. It is the first cost you give is the cost that needs to be delivered. So it's an important role the cost manager plays in trying to envisage and make allowances for all of the final products. At more specific Revit items, again, talking about families and categories, we said that Revit makes use of families in which the various model objects are contained or created. But it's important for modelers to note that every element or object in a model must be created in the correct family or category within Revit. So by way of example, ceilings should be modeled using the ceilings family and not in a family such as floors. Further examples being kitchen countertops, which should be modeled in casework family and not in a floors family. An example of this I had is that where a stone countertop to an apartment, a joinery fitting in an apartment, was modeled using a road surface floor. And when you're extracting purely based on object properties and without visual inspection, it becomes very confusing as to what the model author is trying to portray by that component. Similarly, structural columns should be modeled using the structural category and not necessarily the columns category. But in instances where modeling best practice don't align with the direct category, for example, bulkheads being modeled in walls using the walls family, it's very important that the type name of the model object is clearly indicating the intended finish of that element and must be noted as such in the BEP. And this talks to family naming and object naming. It's important to note that we are now looking, and some of the challenges we've got is that we're looking at your object properties and the definitions and the information behind the visual representation of an object. And where that doesn't align, that causes confusion and potentially is a reason why cost managers are sort of throwing out the 3D model. So where possible, object type naming should accurately describe the shape, the makeup, the material, and if possible, the sectional dimensions of an object. Sectional dimensions actually are very important, and if they're modified, this should be done by creating a new object type with the naming appropriately amended to reflect this revised dimension. It's critical that modelers include sectional dimensions in the object dimension properties, and that these match the type naming. We're speaking to our software vendors and our takeoff and estimating vendors so that we can try and build formulas that build up descriptions for estimates based on the object properties, not necessarily based on the type name. And what we can then do is we can see if there's a mismatch between what the object properties are telling us and what the type name is telling us. And we can raise that as a flag so that the model author can correct it, of hopefully improving model data quality. But again, issues and challenges if the model objects aren't correctly populated. Then we struggle with some of the tools that are there in terms of efficiencies for model authors. So Revit makes use of tools called model groups, composite objects, nested families, assemblies, and parts. And these multiple modeling tools are intended to provide improved efficiencies for the model author by way of minimizing repeat tasks associated with modeling multiple objects. And while these tools improve modeling efficiency, they often reduce the transparency and accessibility of the model data to which they have been applied or used to generate. So if we look at model groups, for example, model groups will allow multiple elements and objects to be locked for editing, then copied and applied multiple times in a building or in a model. Autodesk suggests that the grouping of elements is useful when a modeler needs to create entities that are repeated or are common to many building projects. So items such as repeated hotel rooms in a hotel development or apartments, or even floors that get repeated. These could be created as groups and repasted. And what this allows is that with each instance of that group, when the modeler places it, and if they modify a wall, for example, in one group, it changes all instances of that wall within each group that is applied. And therefore it simplifies the modification process. And one change can be replicated hundreds of times. However, for quantification, the use of groups prevents the quantity surveyor from being able to quantify the objects within a group. They're kind of hidden behind a curtain. And this is as the object data sits behind the protection of the group. So as a result, what we've needed to do in order to access that, in order to classify it and pull the quantities out of those objects, is we've needed to ungroup those model groups. And this is done by selecting the entire model, filtering for groups, and clicking ungroup multiple times until we've removed them. But the problem with that is if we're doing that in a live model, we are editing the model author's efficiency. And if they need to come and make a change at a later date, we've now removed the tool that allows them to make that change efficiently. So we need to be very careful about who's going to do that. And if model groups are used extensively and we need to quantify based on that, we possibly need to make an export of that Revit model that can then be ungrouped and have the estimate based on the ungrouped model that sort of sits on the side. The detractor from that is that we're no longer working in a live collaborative environment. And again, it goes back to that sort of information take process that quantity surveyors are used to, as opposed to developing the model for the whole team. And we've mentioned composite objects and families and nested families, and similar action, but very specific action needs to be taken for each of these types of groups. For example, stacked walls, and how do we unstack a wall, and the efficiency that can be achieved by modeling with those components, but also how they prevent us from being able to identify the objects and quantify the objects within that grouping. We can then look at my absolute hate is generic models. As far as I'm concerned, it's not recommended to use generic models as a Revit model category, except where it's representing, or that generic model is representing, an off-the-shelf item that has the appropriate product specification in the object data. If an object cannot be defined and a 3D placeholder is required, then a generic object may be used, provided that object is clearly defined and appropriately labeled. This use case should, however, be avoided, as generic models do not contain any dimensional information other than the volume. And believe it or not, it's very invariable that quantity surveyors will actually use volume in estimating. Other issues we find are things like the dimensions or cut length and length of footings and beams and walls, or even the location line of an object. Quantity surveyors need to be aware that Revit models in very specific circumstances make two dimensions that are effectively referring to the same thing. And the most relevant example of this is the difference between cut length and the length of a structural framing object, or the cut length and length in a structural framing object. Using a footing as an example, the length of that footing is the distance from the start and the end point of the modeled framing element. And those model framing elements are invariably the columns that the footing is modeled between. And so this will include some overlap with the elemental support for that footing, or for that column, which is the base. So we would effectively have two bases below a column and a strip footing modeled between them. But the cut length, which is the dimension we would want to refer to, is in fact the clear distance between the edges of the two bases of that framing element. So when modeling, ensure that if you are using structural framing elements, that the cut length is a component that is visible to the quantity surveyor. So otherwise what's going to happen is they're going to look for the length dimension, and they're going to manually scale it on screen as well, and they're going to get a different dimension, and therefore feel apprehensive about using the model object properties. It's important that Revit allows modelers to select also a wall location line as a property, and this location line determines in the wall's vertical plane where the wall will be positioned in relation to the path that it's been sketched. And the wall location line also influences the length on plan of that wall. So if you're measuring to the outer corner of a wall or the inner corner of a wall, or obviously the center, and typically quantity surveyors will measure to the center of the wall, but it also can be carried through to the structural footing that is then bound to that wall and has a knock-on effect to the length of that footing. Another issues we found, or challenges that we found, relate to phasing, or phasing not being used and not referenced correctly in model objects. So all model objects need to indicate their phasing, and phasing is especially important when works are taking place in existing buildings. So by applying phasing properly and as a property to an object or element, it defines whether the object is an existing object or a new object or an object to be demolished. And naming these phases must remain consistent throughout the objects in the model. And it can be created as a property as phase created or phase demolished. And it allows us to separate the exact same type or instance of an object, but whether it be an existing wall or a new wall. And therefore we can measure those components correctly. So what we detail in our object geometry and property section are some of the challenges that we face. But the simplest way to think about it when modeling an object is to say that we should model the geometry to represent the way that each object will be built in reality, and try and imitate how it will be. And that the integrity of the 3D model shouldn't ever be compromised to facilitate a 2D representation of elements. We need to take that mindset of detail from a 2D layout and apply it to our 3D model, and move away from 2D representations and move that 2D detail into our properties. So when we look at one of these issues in terms of objects and overlaps and intersections, elements should be modeled to be dimensionally accurate. Elements shouldn't intersect with each other, and that would mean an intersecting or an overlapping geometry would potentially mean that there is a duplication of quantities. But, you know, any duplication of quantities being on top of each other will result in additional quantities being measured. Likewise, structural connections. It means note that all modeled objects should be connected. Nothing should be floating. And that is to say there shouldn't be any gaps between objects, because a gap would imply a shortfall in the quantity of one or more of the modeled objects. If all modeled objects are to be modeled to the correct tolerances and constraints, and then we note that the quantity surveyor, if they identify a gap, would need to check a linked model, because it's possible that the gap on one model is actually completed by the object modeled on a structural model, for example. So make sure that you're checking the federated models and the linked models to see if there's anything that is missing. Because if the object is not modeled, it can't be quantified. Similarly to the phasing property, the function property of an object allows an object to have its functional location identified. These locations are interior, exterior, foundation, retaining, or soffit or core. But from a quantity takeoff and a model that clearly identifies the functional location of objects, it's critical to aligning those objects to the same category in the classification and in the method of measurement. So with regard to the guide that we use typically in South Africa, the ASAQS Guide to Elemental Estimating, the first three are important, those first three being interior, exterior, and foundation. And having those functions applied to each object allows us to start building algorithms that looks for object properties and correctly applies a classification code. So by way of example, external walls and walls forming the facade of a building must have the function property set to external. And external walls shouldn't host any windows or doors named or that have a functional property internal. Likewise, internal walls and doors shouldn't host windows or doors that have the functional property as external. So again, it's a way of checking and making sure that the data integrity of the model is maintained. Another item being elemental separation. This talks to elements forming folds or protrusions from an element within the same family. And that we're saying that they should be modeled using different items. So by way of example, a column head or floor drops should be modeled separately, with the column head being modeled as a separate object from the balance of the floor or the slab. So this is in order to make sure that the associated concrete and formwork can be quantified separately. Possibly one of the most important challenges that we come across is vertical repetition. So basically asking that model objects that run through multiple floors be split per floor and modeled per floor. These objects should be modeled from slab to slab and not necessarily floor to roof. And that model author should apply the rule of modeling according to the construction methodology or sequence, and how their dimensions and the integrity of the forming those objects will affect the different phases of construction. It also goes down to assisting us in zoning and applying costs to different functional areas and categories of the building. If a column is modeled or a wall is modeled the entire way through a building, we're unable to split those costs, and it comes out as a single sum. So by way of example, columns and walls should be split per floor. Columns and walls also in the substructure or foundation should ideally be modeled as separate elements from the superstructure and covered also using that function to state that they're in the foundations, and that's added as a property. Likewise, external elements should be split from internal elements. And then one of the other issues and challenges we have, going back to if it's not modeled, it can't be quantified. It relates to finishes. So typically finishes to surfaces are not modeled as separate objects, and therefore will not be available to the quantity surveyor as quantities that can be extracted from the model. The quantity surveyor is therefore dependent on the objects to which the finishes will be applied in order to obtain the appropriate quantity. However, unless each object in the model representing the extent of each type of finish is modeled representing the extent of each type of finish, then the quantities extracted from the base object will not sufficiently or accurately represent the quantity of the finishes. So this is to say that if a single wall run had multiple finishes on it, that wall run would have to be modeled with multiple types of objects. And that's typically not the case in modeling practice. So where possible, we could use parts to resolve this, and parts can be used to represent the base object and the applied finish in a single object. And in all other cases, the applied finish, if not modeled separately, should ideally be listed as a finish parameter or property. But as I said, that will obviously result in additional objects being required to accommodate the different finishes for each object. Now, what's key to understand is that the quality of the data in the model and the accuracy and usability of the model itself is entirely dependent on the human inputs into that model. The principle of garbage in, garbage out very much applies to the data extracted from a 3D design model. Further, it's even if the model is meticulously modeled and that all data reference is cross-checked for accuracy, we need to be aware that 3D design intent models are categorized into levels of information need and levels of development. So this is to say that the amount of detail in a model improves over time as information is added to its various design stages and through the various construction stages. So this takes us back to the earlier point, which indicates that not all quantities needed during takeoff can be extracted from the model, because not all quantities are modeled at every stage of the design progress. Similarly, not all items that would typically be considered measurable are modeled. This is the objects in a model are just that. They are graphical placeholders for the finished object, and they don't necessarily represent quantifiable details of all of their measurable parts. And therefore, they don't necessarily have all of the dimensions or the information required in order to cost that object. So we need to, if we're putting placeholders in, we need to ensure that those placeholders contain information so that a cost can be allocated and a provision can be made. Now, we've covered some of the challenges, or a number of the challenges that we experience with regard to quantity takeoff. And now we need to move on to the second section of 5D, which is cost estimating and the challenges associated with that. And cost estimating is typically done in isolation once the design team has reached a certain stage. And one of the reasons for this is that cost estimating and scheduling is traditionally an information take process. This is because information flows from the design team to the quantity surveyor, who then interprets that information and presents it in the form of a cost estimate. So this further perpetuates the misconception amongst quantity surveyors that BIM and 3D models is a design tool, and that there is not necessarily a place for quantity surveyors in BIM. It further becomes a problem because that model and that design information is detached from the work in progress and the workflow of the design team before being issued to the quantity surveyor or the cost estimator. So we have issues with regard to revision control because we're not working on a live version. And any manipulation of the model after receipt from the design team needs to be repeated for every revision. So there's a lot of rework in that process. Revision control is therefore very difficult to manage when the quantity surveyor is adding content to a model that is detached from the design team's workflow. This is where we must look to start and where most of the impactful contributions by a quantity surveyor can be made. The quantity surveyor needs to be able to apply data directly to the 3D model and must provide the direction on modeling of objects to better match the construction required in the real world and the method of takeoff required for that specific geography. And that specific geography is important because, as I said, different measurement rules apply to different regions in which buildings are constructed. So South Africa applies different measurement rules to other African countries, and likewise Europe and the UK and Ireland and the Middle East have different measurement rules for the purpose of their estimates and the purpose of their bills of quantities. So what we realized was that we started to become aware of various challenges facing 5D BIM and the reason behind cost managers being reluctant to trust 3D models. And this was that we had now, because we had identified these challenges, we had a roadmap that could guide us towards solutions for more effective engagement with these models. We therefore set about creating a live document, the cover of which is on screen, which can be updated on a regular basis and to better align with our evolving company and industry standards, and thereby developing our capabilities for our teams as we expand our portfolio of BIM-enabled projects. The document covers all of the known challenges that quantity surveyors encounter when basing estimates off the 3D models. It provides solutions on how to resolve these with the design team, and these solutions are based on feedback that we have received from the designers themselves. The document further acts as guidance notes that the design team, for the design team with regard to modeling best practice and the requirements in order for the quantity surveyor to be able to rely on the object data in a 3D model. The document makes recommendations based on 5D friendly modeling in terms of best practices, and this is done in an attempt to standardize the output of 3D models in a format that is 5D compatible. We believe that by applying the guidance in this document, the need for manual takeoff will be greatly reduced, with the ultimate goal being that we will be able to develop consistent modeling best practices. And this will improve the usability of the model data for all stakeholders involved in a project. The document effectively covers three main sections and has three main premises. The first being the involvement of the BIM execution plan. And while the BIM execution plan is intended as a tool for managing of project information, it invariably becomes a design-oriented document. The quantity surveyor must ensure that frameworks agreed to in the BIM execution plan provide for the information to be communicated in a manner that is 5D friendly. BIM execution plans should further list the agreed project goals for BIM, stating the intended level of development that the model will be taken to, and the BIM uses that will be contributing to the model, such as 3D, 4D, and 5D. The BIM execution plan will need to state the agreed project workflow, which defines where information will originate and the required development path that information needs to flow through the various design disciplines. And this would be a very appropriate point for cost managers to indicate when particular information should be provided to them. Importantly, the level of information needed at each design stage of the process. And well before a quantity surveyor can apply a parameter to the model, or apply a classification code to the 3D model, we should, as quantity surveyors, should be contributing to the development of the model through a common data environment that allows for collaboration and commenting on the progressive development of that model. We recommend that quantity surveyors be invited to a cloud-based system, such as BIM 360, and that the quantity surveyor must undertake a review of the model at appropriate intervals in order to comment on the geometry of the modeled objects and the parameters applied to them. By undertaking these reviews, the quantity surveyor can inform the model author as to the objects that do not meet the requirements of the quantity takeoff rules that are applicable to that model's geography. The comments can be linked directly to the objects that are being reviewed, or they can be made generally on the model as a whole. But further, the comments can be addressed to individuals who will be responsible for actioning those comments, and thereby creating an action item list or a to-do list for the model authors that they can work through. And then, as said, the intention is to allow quantity surveyors access to the model to apply the 5D parameter. Quantity surveyors should be responsible for applying the 5D classification parameter themselves. So this avoids burdening the design team with this and ensures that the quantity surveyor takes responsibility for this classification and the integrity of the data that they apply to the model. And by applying a 5D classification parameter to each element or object in the model, the quantity surveyor is required to interact with each object, or at a minimum, each element type in the model. And during this process, quantity surveyors can provide comments in a live environment that the design team can review and respond to prior to the design becoming so advanced that significant abortive work is generated. And in order to undertake this task, the quantity surveyor will need to be included in the design workflow, so as to apply the classification to the model elements at the appropriate time and to the appropriate model. Now, this classification then allows the quantity surveyor to later extract quantities from the model according to the data applied using different search criteria and automated measurement formulas can be defined in our chosen measurement software. And as the classification is applied to federated models that the design team are working on and will continue to develop, the code then lives on in the model through the various stages of design. So that reduces the amount of rework associated with managing revision control and checking existing codes and applications. So we simply make sure that all objects are coded with the correct code. And if a new item is added to the model, we apply the code to that. Now, the classification parameter also is a process-driven solution, and it does not stipulate which classification needs to be applied, but further makes provisions for a chosen classification that's applicable to a geography. This is quantity surveyors around the world are required to take off quantities based on the governing formats in their region. And by applying by providing quantity surveyors with the ability to apply data directly to the 3D model, the quantity surveying process using BIM and the estimating process will be fundamentally the same as traditional quantity surveying, but with the added benefit of improved data quality. So this will allow quantity surveyors to have increased time to spend on value-add processes, which could have a benefit for the overall project as a whole. But in order to do this, what we require is development in terms of the applications and that we use and the software development, so that quantity surveyors can apply data to the model, but without having the ability to edit the model properties or model geometry itself. This, as the design responsibility and the integrity of those objects dimensionally needs to still rest with the model authors. So at face value, those suggestions and allowing quantity surveyors the ability to comment and for model authors to make changes based on those comments, they impose greatly on the design team, and incorporating quantity surveyors' recommendations may initially result in additional design time required to meet these demands, which are of the proposed best practice. But it is hoped that the burden of accommodating these requests will be outweighed by the benefit that they offer to the project team. For designers, we hope to have more integrated designs, with value engineering being able to happen faster than before, and potentially with less rework. For quantity surveyors, we hope to be able to do more automated and well-connected takeoff. For project managers and planners, 5D modeling best practices are very similar to those that they require for 4D, and 4D and 5D simulations can then be created to de-risk project construction schedules and by improving stakeholder transparency. For a contractor, Better quality models with 4D and 5D enabled data will improve the quality related to future virtual design and the construction usage of those models. From a client or developer's perspective, the cost estimating will be done largely in parallel with the design as we're interacting with the live model. So meaning that we should be able to achieve faster project design turnaround times. And with the key that we'll have improved cost transparency. Now, what's key to note is that this process is exactly that. It's a process that is a global solution. It's a suitable system that can be implemented in many geographies simply by changing the code set that is applied based on the local code set in that region. So, for example, the ASAQS code set in South Africa, NRM1 in UK and Ireland, and in the Middle East. But for the industry to actually harness the potential of 5D, it requires that all stakeholders work together to achieve the aspirations of true 5D. There will be cases where professionals work together to enable 5D purely in a collaborative environment without direct instruction from the client. However, we believe that in order for the industry to adopt and speed up the significant movements for this 5D friendly models to become part of the process, that they need to become part of the contractual scope. And if planned for upfront, many of the concepts that we talk to and many of the suggestions in terms of the 5D friendly best modeling practice can be implemented with limited disruption to the model authors. So, in summary, we had a number of challenges and we've proposed some solutions. The key amongst those is that the collaborative approach of BIM and its encouragement of developing efficient digital tools will allow quantity surveyors to access and contribute to the design and the delivery process for improved project outcomes. It's essential that quantity surveyors understand the design team approach, both in terms of best modeling practice and in the process of design development. This needs to be throughout the life cycle of a project. Quantity surveyors should encourage their involvement from the outset of a project, communicating with the design team effectively while simultaneously guiding the design team and the modelers as to the requirements of a 5D friendly model. And by developing and promoting best practice in 5D friendly design models and for cost managers, we intend to be able to provide a starting point for future development, have a conversation. And in this conversation, we hope to have a common language which we can use for upskilling and educating our project teams. And thereby provide an industry-specific approach that is applicable to all design disciplines. And by contributing to the development of the 3D model in a 5D-friendly manner, based on clear and easily accessible guidelines, we hope that the quantity surveyor will be able to achieve fast, reliable, accurate quantity takeoff based off the 3D model that is categorized in terms of cost reporting and estimating by the use of zones and locations, which will have an efficient process in terms of updating those costs based on future design revisions, and most importantly, have improved visualization of the elements that are going to be measured in the quantity takeoff for costing purposes, which results in enhanced communication and collaboration amongst the project team and the professionals. But to achieve this, it's critical that quantity surveyors provide input in a common data environment early in the design process. And this is to ensure that models are set up with appropriate geometry that is correctly split according to the cost benchmark guidelines for their region. Thank you for your time today. I hope you found this session informative, and I look forward to engaging with you on these topics in the future.